The unit step is another important function in signal processing. The definition is mu of t is equal to 0 for t less than 0 and 1 for t greater than or equal to 0. Let's plot it alongside the delta function. Recall that integration is the summing of the signed area of a function. It should be apparent by inspection that the integral of the delta function is the unit function, and that the derivative of the unit function is the delta function. Let's do an example. Plot the following function. F of t is equal to mu of t plus 2 minus mu of t minus 2. The unit step is often seen in pairs like this. Plot the two unit steps in the function f of t separately, then perform the subtraction visually. This is a common method when learning signal processing. If you're uncomfortable with shifts in the argument of a function, write out a table with a few test points to figure out what's going on. Once the subfunctions are plotted, perform the subtraction. We find that f of t gets turned on at t equals negative 2, then turned off at t equals 2. As always, I suggest just playing with the function to gain an appreciation. The unit step in discrete time is defined pretty much exactly the same as in continuous time, only now the input is an integer. We say that mu of n is equal to 0 if n is less than 0, and 1 if n is greater than or equal to 0. It is 0 at every integer before 0, and 1 at 0 and every integer after. Let's do an example. Plot the function g of n equals mu of n minus 1 minus mu of n minus 2 plus cosine of pi n times mu of n minus 5. Break g of n down into subfunctions and plot them individually. Our first term is just the standard unit step shifted to the right 1. Our second term is the unit step shifted to the right 2. Our third term is cosine of pi n, which is 1 on all the even integers and negative 1 on all the odd integers. Make sure to verify that on your own if it's not apparent. And the fourth term is a unit step shifted to the right 5. Once the subfunctions are plotted, perform the operations visually to plot g of n. I've chosen this example to explore two key points: the relationship between delta functions and unit steps in discrete time, and the unit step's interpretation as a switch on or off when multiplied by another function.